Hello, hello, hello. I believe we have an assignment to go over on ratios, proportions, and percentages. Um, Before we start, I wanted to say really appreciate people making an effort to get help meeting at 2. There's 6 or 7 of you guys that seem to be there regularly asking lots of questions. Now, I do want you guys to try the problems before you come, if you can. I know that sometimes you got other things you got to do before that time. But let's say you're working on the problem later in the afternoon or even in the early evening. Let me know what problems you're getting stuck on, because when I make these videos, I'm not always going to have time to go over every problem. And I do want to do the ones that people are getting stuck on. So keep that in mind. Okay, shoot me an email, leave a message on the assignment on Classroom, one way or the other. I will know which problems are the most important to go over. With that being said, let's look at some answers here. Number 1, we've got 5 of 12 people in a chess club are female. The rest are male. So 12 minus 5 would be 7. What's the ratio of females to males? Well, there it is. We just said it, 5 to 7. So that one was just basically a subtraction problem. Number 2, fire truck, little toy fire truck, has 2 gears. A front one that has 5 teeth, or 5 will go around 5 times, and then a rear gear that will go around 8 times. Every time that the truck is pushed. So if the front belt turns 800 times, how many times will the back turn? Whenever you're dealing with proportions, we always want to understand what the proportions are. So if I'm dealing with a front gear and a rear gear, I'm going to call my proportion front over rear. And then I'm going to circle the important parts of my problem. 5 times on the front, 8 times on the rear. So that ratio is going to be 5 to 8. It's really important now that we understand which of the colors, yellow or green in this case, is the 800, because it needs to correspond with either the front or the rear. I think a lot of people, without even glancing, will just want to put the 800 in corresponding with the 8, because they have the 8s. But in this case, that's not what it is. It says it's the front, so it's not a yellow. It's actually a green. And so once you set it up, cross multiplying and solving is pretty simple, but you got to be careful that you're setting your ratios up in a proportion in a corresponding manner. Okay. Number 3. Actually, number 3 and number 4 had a very similar tone. They both talked about partially filling something within a certain amount of time, within a partial time. And so I think the equation that you want to be dealing with here is we know that if we did the full time, the partial time divided by the full time, I would get the percentage of fill. But you can multiply that equation and get this equation right here. The percentage multiplied by the full time that it would take to fill. So I guess you could also call this the fill time, if you wanted to, right, is equal to the partial time. So once you kind of have that established, it makes these problems really just plug it into an equation. An oil tank is 3/5 filled, so that's 0.6 or 60%. So that's our percentage. All right, 3/5 is our percentage there. The full time we don't know. That's what they're asking us to determine, or at least to write an expression for. But the partial time that it took to do 60% of the tank was 6 minutes. So that's this. And so now we have an equation, and it actually exactly fits A, except we had to turn 0.6 into 6/10 or 3/5. We had to turn it back into a fraction. So I think that's the easiest way to attack this kind of a problem. Use that relationship right there. This is a different way of doing it, where we're doing part over whole. So the part that is filled, 3 over the whole tank, 5, is equal to the part of time, 6, over the whole time, which we don't know, x. So we would probably want to cross multiply here and divide, and we get 10, and then 6/10 would be the same 3/5. Would basically, if I just multiplied this by x, I get the exact equation that we got doing it the other way. So just another way of looking at problem 3. You'll see problem 4 is along the same lines. The percentage of the fill that we get multiplied by the full time it takes to fill it will always give us the partial time to get to that percentage of fill. So it looks like 1/6 of the day is the time that it took. So let's go ahead and give that a color. 1/6 is the partial time. And the percent of the pool that was filled, about 67%, right? 0.66667, 2/3. That's the part of the fill. So we don't know how long it's going to take to do the whole pool. But if I multiply by the reciprocal of 2/3, which is 3/2, which we do right in this line, we get 3/12 or 1/4. So a quarter of a day, which would be about 6 hours to fill the entire pool. A couple other ways of looking at it. If 2/3 is 1/6 of the time, I could, or 1/6 of the day, I could say, well, then if I broke that down into 1/3, it would have to be half of that 1/6, which would be 1/12. So since 2/3 is 2 out of 3 parts, I would get 1/12 plus 1/12 would be enough to fill the first 2 parts of the pool. That's the time I need for the first 2 parts. But because there's still a 3rd part left, I would have to add that in to get the full fill, which ends up with 3/12 or 1/4. You can see we get the same answer. It's another way of thinking about it. That might make more sense to some of you. And then finally, the way that we have over on the side is just setting up that proportion. 2 parts full out of 3 is 1/6 time out of x. So it's kind of like doing this way that we did it up here. Okay, setting up that part to whole equation. Part of the fill over the whole fill equals the part of the time over the whole time. Part over whole equals part over whole. And you can see that cross multiplying, I get the exact same answer, 1/4. So a number of ways of doing that one. That's usually a problem that a lot of students do struggle with a little bit. So hopefully that was helpful. Moving on, number 5. This one can be tricky unless you kind of look at them in different ways, okay? Like instead of looking at them with the colons, let's look at them as fractions. Now, when I cross multiply the original proportion, I get 3y, right? 3y equals 35. 3y equals 35. Only one of these proportions gives me the same answer. For example, A would give me, 7y equals 15. So that's different. 5y equals 21. So that's different. But look at C. 3y equals 35. So there's your winner. Winner chicken dinner. Now, there is another way to attack this, especially if you really knew your proportion properties from back in the fall when we were doing similarity. One of them said that if a if a proportion is true, then the reciprocals of those two ratios would create another true proportion. That was called the reciprocal property. And then another one said that if you interchange the means of a proportion, you get another true proportion. So if I have A over B equals C over D, and I flip the means, which would be B and C, so now it's A over C equals B over D, that's a true proportion. And if you combine properties 2 and 3 by starting with y over 7 and 5 over 3, and taking the means and flipping them to y over 5 equals 7 over 3, and then taking the reciprocal of that, boom, you end up with that right there. So if you apply property 3 by flipping the means, and then apply property 2 by taking the reciprocals, that's another way. I think this way is quicker and probably more straightforward. So not that I always am right, but that's the way I would attack it. Number 6, first I would rewrite 3/5 x as 3x over 5 so that it's easier to cross multiply. Once I cross multiply, I get 12x equals 30y. Now, keep in mind what you're trying to find, x over y. So I want to keep the x up top, but I want this y right here to go away. So let's divide by y. See, now I have x over y, right? That's what I wanted. So I just need to divide by 12 to finish this problem. And 30 over 12 reduces to 5 halves, and that's your answer, C, 5 halves. Let's go to number 7. Yeah, a couple different ways you could attack this one. I think the easiest one is to say, you know what, if 1 over m equals r, then 1 over r equals m. It would be like taking this equation right here and multiplying both sides by m to get the m off the bottom, but then dividing both sides by r. And look, you'll get this equation right here. So if you do that, what you realize is that m and r basically have to be reciprocals of each other. But since 1 over r is equal to m, we could come up here and say, well, when I cross multiply 7 times m, 3 times 1, m would have to be 3/7. Okay. Now, another way of looking at this would be to, once again, cross multiply 7m equals 3, m equals 3/7, and then realize, oh, r is 1 over m. I could put the 3 in there, figure out that 7/3 is the reciprocal, so the reciprocal of 7/3 is 3/7. Just a little side note, when you have y equals a constant times x, y equals kx, that's a line that goes straight through the origin, and it has a slope of k. And this is just a linear equation, but it's because it goes through the origin, it has a direct variation. X and y are directly connected by k with no other values. Now, if I move the x to the bottom, so it's y equals k over x, now y and x are said to have an inverse variation. And what that means is that they have to be, in essence, reciprocals of each other. If I solve for x, look at that, I get the exact same equation, but in terms of y under k instead of x under k. So just a little reminder of something we talked about in Algebra 1. Number 8 was just a kind of a scale factor problem where we had to understand that the dimensions were 10 by 19 and then use that to reduce and find the scale down answer. So pretty straightforward. If you just set up the proportion, you can let me know if you have any further questions on that one. Number 9 was a little trickier. Anytime you introduce multiple variables, so now I have M, A, and B, 3 variables, it gets a little trickier. But if we read it right off the bat, A is 20% of B. That means that A is equal to 0.2B right here, right? And what I can do then is go into the equation they gave me, M is equal to 2A, and just substitute what A is equal to, 0.2B, in for A. So we're going to take A and turn it into this, because this tells me that they're equal. And so there's your answer pretty much right there, right? 40%. It has to be what M is related to B. M is 40% of B. 0.4 is 40%, not 4%, right? 0.40. Number 10, at South High School, the ratio of male students to female students is 5:3. So the missing part they don't give you is the ratio of total students. But we can get that by saying, hey, if the male parts are 5 and the female parts are 3, the total parts have to be 8. So that means the fraction of the whole school of females is 3/8 and of males is 5/8. In this case, they asked me for the female percentage, so 3 divided by 8, right, is 37.5%. Number 11. This one usually gives people a little bit of trouble. Harry is 20% faster than Pete. So that means that, if we say that Pete is 100%, Harry would be 120%. Okay, so 1.2 Pete's equals Harry. That means that Harry is 20% faster than Pete. Now, what a lot of people will just say is, well, if Harry is 20% faster than Pete, then Pete is 20% slower than Harry. But when we switch the orientation from one person to the other, the total changes. So I'm not dealing with a total anymore of 100%. I'm now dealing with a total of 120%. And so to solve for Pete's relation to Harry, I have to actually divide by 1.2, which is like dividing, 1 by 1.2. You could also multiply the top and the bottom by 5 to get rid of the decimal. But 1 divided by 1.2 or 5 divided by 6 is the same percentage. It's about 83.2%. So, when you subtract that from 100, you only get 16.7%, not 20%. Another way of doing this, especially on like a PSAT, SAT question, is to say, I'm going to give them like speeds. And the speeds can be generic. You can make numbers that are nice to work with. Like you could say, you know what? Since Harry is based on Pete, I'm going to make Pete just a nice even 100 whatevers, right? Feet per second or whatever. 100 is Pete's speed. So 20% faster than that would be 120. Notice the difference between them is 20, which doesn't seem like a big deal, except that when you use 100 or 120 as the total, it becomes very different, okay? If Pete is the one that you're basing this on, he's 100%, then that means Harry compares to him as 20 out of 100 or 20% faster. But if Harry is what we're calling 100%, then we're taking 20 out of 120. So we would say that Pete is 16.7% slower. Another way of looking at that problem. Number 12, Victor must pass his clarinet, must practice his clarinet for T minutes. But he only practiced for D minutes before he stopped. So the total minus D is how many minutes he still has left. What percentage of his practice did he not finish? Well, in minutes, it would be T minus D. But the total, right, the total would be T. Now, this is assuming, they didn't tell us this, that D is actually less than T. What if you practiced over the time you were supposed to? That's probably not what they meant, but they probably should have said that. So anyway, you could also go back to our percentage times full time is equal to partial time equation, where the full time was T and the partial time was T minus D. But if you take this this fraction, t minus d over t, and multiply it by 100, it turns into a percentage. So that's why a is basically this fraction, right? Just multiplied by 100. Number 13. So we have 60 juniors and 30 seniors, and they do a ropes course in the first day. 20% of the juniors and 40% of the seniors pass. What is the total percentage? Now, what a lot of people will do is just be like, well, I'm just going to average 20% and 40%, so 30% of them pass. But you can't do that because there are a higher percentage of seniors passed, but there's half the number of seniors. So what we have to do is kind of break it down. First, let's look at the juniors. Okay, 20% of 60 of them passed, so that's 12 campers. Now, as far as seniors go, 40% of them passed, but there's only 30 of them, which coincidentally is also 12. So out of all of the campers, 12 plus 12, only 24 passed. But how many total campers were there? Oh, I guess there were probably 90, right? 60 plus 30. And so if we run that calculation, we will get 26.7%. Number 14. If 150% of J is equal to half of K, so 1.5J equals 0.5K, then what is J over K? So this is similar to one of the earlier problems we did where we had to create a J divided by K relationship. That probably means that we want to leave the J here in the numerator and divide everything by K. Okay, so if we do that, we'll get J over K. But that means I need to get rid of this 1.5. So let's divide both sides by 1.5. And so what I end up with is just a couple algebra steps is J over K equals 0.5 over 1.5. And of course, everybody knows 50 cents goes into $1.50 3 times. So 1/3 would be the answer. Number 15, if J is equal to 4L and L is 20% of M. So there's our equation we have to write. L is 20% of M. So M times, right, 0.2 equals L. So now I have a value that L is equal to, which I can, of course, substitute in for L. So 0.2M equals 4L. And now we just have to multiply 4 times 0.2, which turns out to be 0.8. So 0.8M, this tells us that J is, I'll do this for you, J is 80% of M. And that's the answer, 80%. Number 16, Gia went to the movies with her 7-year-old daughter and her 70-year-old mother. Movie tickets are half price for people less than 12. So the daughter is going to get in for half price, and the mother is going to get in for a 20 or 25% discount. That's the grandmother, right? So if Gia is $8 a ticket, so that's the normal price. She's paying $8. Well, remember her daughter got in for half that, right? 50% off, so $4. And her mother, the kid's baby's grandmother, got in for 25% off, so 75% of 80 or of 8, or 8 times 3/4 is 6. Okay, so the total that they spent was $18. But remember what they were supposed to spend? Well, the tickets were $8. They were supposed to spend 8 plus 8 plus 8 for $24, right? Well, that means they only spent 3/4 of the total cost, or 75%. So D is the answer. There's another way of thinking about it. 8 cuts so nicely into fourths, right? 2 plus 2 plus 2 plus 2. So Gia paid all 4 of those parts. Her daughter only paid 2, and her mother paid 3. But check this out. What if I moved one of her parts over to her daughter? Now each one of them would be kind of like paying 3 out of 4 parts. Oh wait, 3/4. 75%. So that's kind of another visual way of seeing it. Number 17. Oh yeah, 17 is usually one of the trickiest ones. You really have to break this one down into two pieces. The first edition of a comic book costs the dealer $60. So that's the wholesale cost. They're paying $60, and they want to offer 10% off the retail price, but they still want to make 20% profit. So you can't really go into this one and try to combine the 20 and the 10 right off the bat. I think it would be just way too complex to try to do that. So let's start off with this. We want the sale price, right, to be, oh, wait, hold on one second. All right, thank you. Dog muted him. So we want the sale price to be 20% above what we paid. So 20% over 60, right? So that would be like saying 100% plus 20% or 1.2, right? So we need to sell this thing for, it looks like $72. We need to sell this thing for $72 to get the money we want to out of it. But at the same time, we're trying to convince the customer that they're getting 10% off, right? So I think what we need to do now is say, well, what should the full price be if I want the sales price to be $72? And so why don't we say that 90% of the full price is that $72, right? If we're saving 10%, then that means we're paying 90%. And if you multiply, or I'm sorry, divide by 0.9 here, 72 divided by 0.9, we're going to get $80. So $80 is the magic number. We can discount the book by 10% down to 72, which would still allow the dealer to make his 20% profit. So that's kind of how you break it down. You have to do it kind of two pieces at a time. Otherwise, if you try to do it all at once, it can be very confusing. Number 18 and 19 deal with this chart, which is a sneak peek at tomorrow night's assignment, or tonight's assignment. I guess you're watching this. Probably watching this on Thursday morning, so tonight's assignment. But we're going to be talking about two-way frequency tables. So it's going to give us frequencies of two different categorizations. So like, what grade level are we? Freshman, sophomore, junior, senior. That's one categorization. What kind of math class are we taking? College algebra, Calc 1, or Calc 2. That's another one. And then you can see that these are the frequencies. These are just how many people, how many students are taking each class, and how many total students are down here, right, ended up in the classes, how many total students of each type there are, freshmen, sophomores, etc. And they all better add up to, we'll talk about this tomorrow, 639, okay? These have to add up to 639. These have to add up to 639. So that's how these things work. It's pretty easy to read the tables if you know what you're looking for. It's so important to read the tables or the problems carefully so you know how to interpret it. About what percentage of sophomores and junior students are enrolled in Calculus 1? Well, we're only talking about sophomores and juniors, and there's a total of 368 sophomores and juniors, right? So that is going to be our total. That's got to be the total. But how many of those 368 are actually taking Calc 1? Well, not these. Those are taking Calc 2, not these. They're taking college algebra. Just these, which is 93. And so the percentage of sophomores and juniors taking Calc 1 is 93 out of 368, which your calculator will tell you is about 25%. Notice it did say about, so it's kind of a little bit of a rounding off problem. Number 19 said in the spring of 2014, okay, so this was the fall of 2014, so the previous semester, there were 752 students enrolled in math classes, which is a little bit more than there are now in the fall. Okay. If 38% of those students in the spring were taking college algebra, about how many more students took it in the spring than in the fall? Well, let's figure out how many people took it in the spring. It was 38% of the total, 752, which was about 286. Now, we can easily go up to our table and say how many of our 639 fall students took it. Oh, 256. And so now it just becomes a simple subtraction problem. 286 subtract 256, right, gives us that 30, which is the answer. All right, I think there's one question left, and I'm going to tell you right off the bat. The answer for this last question is A. Yeah, if you don't know Fonzie, then you should watch Happy Days. I'm sure you can find some time to stream that over the next month. Anyway, an investor places $100 into two different savings accounts that earn a different amount of interest. What if he doesn't take any money out, and so we see just the pure interest profit on these growing? Which of these has to be true? Well, here's what we got. They both start at 100. One of them is getting a better rate, and it looks like account 2 is going up faster, right? So I think we just have to go through these and see which one is true. At time 0, the amount in account 1 and 2 is the same. Well, I think we just said that at time 0, these both started at 100. So I think right off the bat, A is looking good. But assuming you have a little bit of time left, right, let's see if these others look okay. At time 5, account 1 has 10% more money than account 2. Well, at time 5, which would be right here, it looks like account 1 is actually below account 2. So it definitely can't be B. That doesn't make any kind of sense. Letter C says at time 10, account 2 has 10% more money than account 1. Well, it does have more, that's for sure. How much more? Account 1 has, about 120 something, and account 2 has about 100, so they're both in the 120s. So 122 to 128, that's only about 6. And 6 divided by 120, honestly, is only about 5%. Okay, it's only about a 5% difference. This wanted us to see if it was 50% more. So definitely that's way too much. So that's not true. And then finally, for the first 15 units of time, the amount of money in account 1 is increasing more quickly than account 2. And we already saw that that's not true. Account 2 is very quickly above account 1 and making more money as we go. So it looks like the only possible true answer is A. That's the end. Remember, I'm not going to have time to do all of the answers really much longer looking into the future. So you guys are going to have to start letting me know specifically which problems we go over. Why don't we start tomorrow? I'll look tomorrow evening, maybe around 5, and see which problems you want me to do for tomorrow night's assignment, which finishes off the packet. I say tomorrow nights, which is Thursday nights. I guess it's tonight, because you'll be watching this Thursday morning. Man, am I getting confused. Take it easy, and the next video coming up will be on those two-way frequency tables. We'll look at some examples of those, and then you can finish that data analysis packet. And then we're going to have to decide, since the PSATs and stuff have been suspended, what are we going to do coming back from spring break? I'll get together with Mrs. Moore, and we'll decide whether we'll keep working on, PSAT stuff, since you'll have to take it perhaps later in the spring. It's always a good thing. Or if it's more important to get back into the geometry curriculum since you never know when they're going to cut the semester short, and we want to definitely finish off the curriculum. We'll see which one of those is going to happen. Nothing to worry about right now. I will talk to you shortly in the next video.